Alright, so this video will be talking about the velocity time graph of a rubber ball. So I'll explain how the velocity changes during the bouncing rubber ball process. Okay, so first thing first, when I drop the rubber ball, the velocity will be 0 meter per second. Okay, so under the influence of our Earth gravitational field, it will slowly increase speed, right? So it will increase to maybe 2 meter per second, and after that 3 meter per second. So the 3 meter per second, I will label it as point number 2. So notice one thing about after your point number 2 is that you go to your speed or your velocity will decrease very rapidly. So you will slowly decrease to 2 meter per second, which is point number 3 right here. Then after that, it will slowly decrease to maybe 1 meter per second, and last but not least, it will decrease to 0 meter per second. Alright, so let me explain what is happening during the from point number 2 to point number 5. Okay, so first thing first, when I drop the ball, so this is point number 1, the speed or the velocity of the ball is 0 meter per second. So after when I drop it, right, it will slowly gain speed. So maybe now instead of 0 meter per second, my velocity is 1 meter per second and is in the downward direction. Okay, so it will gain until before it touches or hits the ground, right, the velocity of the rubber ball will become 3 meter per second. Right, so same thing, the velocity of the rubber ball is in the downward direction, because the direction is very important when we are talking about the velocity. Okay, so after point number 2, we'll move on to point number 3. So point number 3 is where I already touches the ground. So when I touch the ground, the velocity will decrease, right? I will slow down. So I will become 2 meter per second in the downward direction. Then after that, I slow down further. I will further slow down to 1 meter per second in the downward direction. Of course, last but not least, I will move on to point number 5, where I do not have any velocity left. So this is the process from point number 1 to point number 5. Okay, so take note that when I'm moving downward, my velocity is positive. Okay, so it's defined as positive in this case. So for point number 2, my velocity is positive. For point number 3, my velocity is also positive. And for point number 4, my velocity is positive. Right? So that's why if you look at your velocity time graph for this rubber ball, this portion are all positive, in the positive region of the graph. Okay, until point number 5. Okay, so after point number 5, we move on to point number 6 and point number 7. So what is happening during this region? So point number 6, you can see that it is in our velocity is negative 1 meter per second. Right? So let's move on to point number 6. Okay, so negative just denotes the direction. So just now I say that my downward is positive. Now if I want, because I want to move up, so my velocity must be in the upward direction. So my velocity must be in the negative region of the graph. Okay, so of course I slowly gain speed to negative 2 meter per second. So this is in the negative portion of the graph. Alright, so just take note that negative just denotes the direction. Alright, so after point number 7, I will rise up already. Okay, so I'll rise up until I go to point number 8, where my velocity is 0 meter per second. So this is where I reached my maximum height. So I'm not moving down or I'm not moving up at a split second. So that's why my velocity is 0 meter per second. This is also what we call the instantaneous rest. I'm not moving, right? So that's why it's 0 meter per second. Okay. So for point number 6 and 7 is in the negative region of the graph, right here. So from point number 7 to point number 8. So point number 8 is right here, where my velocity is 0 meter per second. So from point number 7 to point number 8, I'm actually moving upward. So after I reach my maximum height, which is after point number 8, I will slowly, not say slowly, I will just go down, right? So when I go down, definitely I must go to the positive portion of the graph already. It's no longer negative, right? Then when I reach 2 meter per second, I will hit the ground again. So how do I know when I hit the ground? You can see which part of the graph is the velocity is changing very, very rapidly, right? So for this part, from point number 1 to 2, I'm moving upwards. I'm moving downwards. So this is the direction. So from point number 2 to point number 5, I'll label it as red color, my direction of the velocity is still downwards. Okay, so from point number 5 to point number 7, right here, my velocity is gaining in the upward direction. Right, so from point number 7 to point number 8, I'm also moving in the upward direction. Okay, and after that, from point number 8, let's call this point number 9. I'm moving in the downward direction. So this is where I'm dropping. Okay, so from point number 9 to maybe let's call this point number 10, I am hitting the ground. Right, I'm in contact with the ground. So additional thing to take note is that from point number 2 to point number 7, it is in contact with the ground. Alright, so so just take note of this. It's very important. From point number 2 to point number 7 is in contact. Okay, so from point number 1 to point number 2 is moving downwards. Okay, then after that, from point number 7 to point number 8 is moving upwards. Okay, so point number 8 to point number 9 is moving downwards. Okay, so after that, point number 9 to 10 is in contact with the ground. So this is how the velocity of a bouncing rubber ball changes over time.